15 years, Anna's age will be the square root of 2025, or in symbol, we have this. What is her age now? You can solve for this problem if you are already familiar with square root. So the focus of our lesson for today is on this topic. So I hope that at the end of this discussion, you can answer this problem. Let us begin by defining what a square root is. It says here, the square root of any number is a number whose square root is the given number. Well, that can be quite confusing if you are still unfamiliar with these terms. So let us have an example. We have here an expression 5 raised to 2, or it is read as 5 squared. Okay, so we call this number down as the base, and this number on top is called the exponent. It means that we would only have to multiply our base by itself based on the exponent. So we will multiply 5 by itself twice because the exponent is 2. So the expanded form of 5 squared is 5 times 5. Okay, so that is read as the square of 5. Now, when we simplify this one, so we will obtain 25. Okay, now we will do the reverse. So this time we are going to get the square root of 25. This now is read as the square root of 25. So as you can see here, we have a symbol for square root, this symbol. It is different from the symbol for division, which is this. Okay, so for division, you have only a straight line and then a bar on top. But for square root, we have this tail. Okay, so that is written that way. Now, the square root of 25 is 5. Now, how did we get that? We have obtained that because we have identified, or we know that the number which we could multiply by itself to get 25 is 5. That's why it says in the definition that the square root of any number is a number whose square is the given number. Okay, so that is the definition of square root. We have here another example. So we also have negative 5 here as the base, and then it is squared. When we expand this, we will have negative 5 times negative 5. And based on our discussion on integers, when we are multiplying two negative numbers, the result is positive. All right, so we can then go back to our expression square root of 25, and square root of 25 can also be equal to negative 5. This means that the square of a number is the positive and a positive and a negative number. Okay, so in this case, the square root of 25 is positive or negative 5. So it depends if it is asking for the negative root or positive root, so you choose between these two. But most of the time we consider only the positive root. Okay, but take note that we also consider the negative equivalent or negative additive inverse of the positive number or the positive root. Okay, so that's it. Let's continue. Now we have what we call perfect squares. 25 a while ago is an example of a perfect square. Okay, so we have here its definition. Perfect squares are numbers that have rational numbers as square roots. Again, rational numbers as square roots. In our next lesson, we will learn about the subsets of rational numbers. Anyway, let's continue. The square roots of perfect squares are always rational numbers. Okay, so we will always come up with a rational number. So to have a quick preview of what rational numbers are, so this includes whole numbers, integers, as well as decimals and fractions. Okay, so we can obtain those rational numbers. Okay, so some common square roots of perfect squares whose roots are rational. So here are some examples. So our perfect square here is 4, but we have a lower perfect square which is 1. And of course, its positive root is 1 and its negative root is -1. Okay, followed by 4, because 4, the square root of 4 is 2 or -2. Followed by 9, 16, 25, 64, 81. The next perfect square here is 100. So its roots are 10 and -10. Let's try this. What is the square root of 49? So it is asking about the square root of 49. It means that we have to identify the number which we could multiply by itself to obtain 49. So what do you think is the result or the answer to this question? All right, the square root of 49 is 7 or -7. Okay, so either of the two or both. Next, we have what is the square of -2? This time we are asked about the square. We are missing the word root. It means that we have to multiply the number by itself twice. Okay, so that is the expression. So we have -2, the quantity squared. So -2 times -2 is +4. So this is the answer to this question. What is the next perfect square after 81? And we have answered that a while ago as well. The next number after that is 100. Since 81, the square root of 81 is 9. So the next number after 9 is 10. When we square 10, we will obtain 100. Next, what is the positive square root of 169? So it is only asking for the positive square root. And what do you think is the number? It is 13. Okay, when we multiply 13 by itself, the result is the number here. Okay, or the what do we call this? Perfect square. Next, so how about if we are given a fraction? Okay, we have a fraction inside the radical sign. So it says there the square root of the rational number of the form a over b, or the square root of ab, can be written and simplified by getting the roots of each term such that the square root of a over b as a whole is equal to square root of a over square root of b. So if it is squared as a whole, we can separate and square the numerator. I get the square root of the numerator over the square root of the denominator. So for this example, if we are going to do that, so we will get the square root of 4 and then the square root of 25. And when we simplify that, the square root of 4 is 2, and the square root of 25 is 5, which means that the square root of 4 over 25 is 2 over 5, or 2/5. So that is the positive root of this example. Okay, we could also include its negative root, which is negative 2 over 5. Number 2, find square root of 1 over 36. So again, we get the square root of the numerator and the square root of the denominator. Okay, the square root of 1 is 1. The square root of 36 is 6. So that is the positive root. We can also include the negative root or negative equivalent, which is negative 1/6. So the roots of 1 over 36 are 1/6 and negative 1 over 6. This time we will discuss about irrational numbers. So irrational numbers are any numbers that cannot be expressed as a quotient of two integers and are the roots of non-perfect squares. So a while ago, rational numbers can be expressed as the quotient of two integers, right? So this time, irrational numbers cannot be expressed as such. So decimal numbers that are non-repeating and non-terminating are irrational numbers. You can check the previous lesson for more examples of rational and irrational numbers. Okay, there's also a note here saying that the square root of non-perfect squares are irrational numbers. Since they are not perfect, so obviously the answers are irrational numbers. Okay, so we have here an example of roots of non-perfect squares that are irrational numbers. So if you will use your calculator and get the square root of 7, you will obtain a non-repeating and non-terminating decimal, which is this, okay, which makes it an irrational number. Another one, square root of 65. If you are going to get the square root of that, you will obtain this number, and it is also non-repeating, non-terminating decimal. Number 3, third example, we have the square root of 315. So it is non-terminating, non-repeating as well. Okay, so we have here an activity. Classifying the roots of real numbers as rational or irrational. So let us check. The root of square root of 12 is 3.4641 and so on. Okay, so what do you think? Is it rational or irrational? It is not a perfect square, and as you can see here, it is a non-repeating, non-terminating decimal. So is it rational or irrational? Okay, it is irrational. And our analysis, the given or the root is non-repeating and non-terminating decimal. How about square root of 100? So square root of 100 is 10 and negative 10. Based on that, is square root of 100 are rational, or are the roots rational or irrational? So of course they are rational numbers because we know that these numbers are integers. Okay, and integers are rational numbers. And as you can see here in the analysis, 100 is a perfect square. Okay, and next one, we have here a decimal, 0.25, and here are its roots, positive 0.5 and negative 0.5. All right, so it is a rational number because it is a perfect square, even though it is a decimal, but it is a perfect square and it is a terminating decimal. Next, the last one, we have 0.4. The square root of 0.4 is 0.63245. Okay, so what do you think is the result? All right, so the square root of 0.63245 the square root of 0.4 is equal to 0.63245, which makes it an irrational number because it is a non-terminating, non-repeating decimal. Okay. Next, we have what we call the principal nth root. Okay. So a while ago we have discussed about square root. Okay. So the principal nth root of a positive number is the positive nth root. The principal nth root of a negative number is the negative nth root if n is odd. And next, note, the principal nth root of a negative number is not defined if n is given. Take note of all of this. And the notation for the principal nth root of a number b is the nth root of b. Okay, so b is our radical, and then we have here the root. Okay, so if it is square root, just simply like that. Okay, if it is like that, it is square root. But if we have a 3, a 4, or other numbers, so we will have third root or fourth root and so on. That's why we have here what we call nth root. So any number that can represent any number. Okay, so find the nth root of the following. So the first one is the nth root of number 1. So we have the cube root of 8. So that is equal to 2. Okay, so why is it equal to 2? Because when we multiply 2 by itself thrice, or 2 times 2 times 2, the result is 8. So this is an example of this one. Okay, since the radicand 8 is a positive number, the principal nth root of a positive number is the positive nth root. So the definition of this, from 2 cubed, which is equal to 8, this means that the cube root of 8 is 2. Next, number 2, we have the fifth root of negative 1024 is equal to negative 4. So take note, it says here the principal nth root of a negative number is the negative nth root if n is odd. Since n here is an odd number, we have 5, it is an odd number, so we will take the negative root of 1024, or its root is a negative number. That's why the result here is negative 4. Since when we multiply 4 by itself 5 times, 4 times 4 times 4 times 4 times 4, the result is 1024. And since the radicand is negative, so of course the result is a negative root. Okay, based on this definition. And next example, the fourth root of negative 81, it is not defined because based on this rule, the principal nth root of a negative number is not defined. Okay, take note. If the given, okay, is negative and it is asking for the nth root wherein n is even, so just say undefined, because if you key that in your calculators, that will be an error. Okay, so here are some common cube root, fourth root, fifth root of integers whose roots are rational. Okay, can you see here? So the cube root of 1 is 1, the third root of 8 is 2. So here are some of the most common perfect cube, perfect, what do we call this? For this is perfect cube. Okay, for this one, these are all numbers. Okay, for fourth root. Okay, so when we multiply 1 by itself 4 times, we will obtain 1. And then 2 times 2 times 2 times 2, we will have 16, and so on. We also have here for fifth root. Okay, so you can check it out before we proceed. or you can take a screenshot of this one, of this table. Okay, now we can proceed. So analyzing and classifying the principal nth roots of numbers. Let us try this activity. So we have 100, or square root of 100. So the nth root, it is asking for the radicand. Our radicand here is 100. And then the value of b, well, that is the value of b already. And then its root is 2. It is asking for the square root, so we are 2. Okay, as I have said earlier, if it is asking for square root, that means that we don't have to put 2 outside the radical sign. And the principal root of this is 10. Next, we have negative 81. Okay, first let us identify the radicand. Its radicand is negative 81, and it is also asking for the square root. So our root is 2, and it is even. And what did we say a while ago? If it is asking for the square root or the nth root, the given is negative and the root is even. So that is not defined. Okay, our third rule a while ago. Next, the fifth root of negative 32. So our radicand here is negative 32, and we are asking for the fifth root. So the root is 5, and it is odd. It is an odd number. Okay, by having an odd number, so it means, and a negative radicand, which means that our principal root is negative. We just have to identify the number which we could multiply by itself to get 32, and that is negative 2. Okay, so negative 2 times negative 2 times negative 2 times negative 2 times negative 2 is equal to negative 32. Next, that is read as the fourth root of 1296. Our radicand here is 1296. It is a positive number, and we are asking for the fourth root. So we just identify the positive root of this number, and it is 6. So 6 raised to 4 is equal to 1296. Next, the third root of negative 125. Our radicand is negative 125, and it is asking for the third root, so 3, and it is an odd number, so that is possible, but our principal root will be negative. Okay, so negative 5 as the answer to this. Next, we have the fourth root of negative 256, and when we get the radicand, we have negative 256. It is asking for the fourth root, and 4 is an even number. So this is same with the previous example. The second problem, this one, it is an even number, and it is, the radicand is negative, so it is not defined. Okay, not defined or undefined. Last, we have negative square root of negative 25. All right, so we have negative 25 as the radicand, and we have 2 as the root. 2 is an even number, and we have a negative radicand, so it is also not defined because that is not possible. Okay, for the next lesson, we are going to determine between which two integers the square root of a number lies. Okay, determine between which two integers the square root of a number lies. Example 1. Between which two integers the square root of 20 lies. So we just have to think of the perfect square near 20. And what are those numbers? Okay, let us recall first. Let's start with 1, followed by 4, and then the next one is 9, 16, 25, 36, 49, and what's next? 64, 81, and 100. So that is from 1 to 100. Those are the perfect squares. So we are it is asking between which two integers the square root of 20 lies. So we have the numbers 16 and 25. Okay, so square root of 16, and then we have square root of 25. That is where we can find square root of 20. So we have here square root of 20, and then we put our notations this way. Okay, so square root of 20 is greater than square root of 16, but it is less than square root of 25. And we know what is the value of square root of 16. That is equal to 4. And then square root of 20 is not a perfect square, so we copy it as is. And then square root of 25 is 5. Now the answer to this example is 4 and 5. Square root of 20 lies between 4 and 5. All right, there. So this is our rule on how we have obtained our answer. To approximate the value of roots in a given number, we must determine between which two integers the square root of a number lies. All right. So that is the same solution that I've shown you. So again, the answer is 4 and 5. Square root of 20 lies between 4 and 5. Next example. Example 2, between which two integers the square root of 75 lies. Okay, so by now you should already be familiar with those perfect squares from 1 to 100. So the nearest perfect square to 75 is 64 and 81. Okay, so we should consider the square root of 64 and square root of 81. So the square root of 64 is 8, and the square root of 81 is 9. So the answer here is 8 and 9. We can find 75 between these two numbers. Okay, because square root of 75 is greater than square root of 64, but less than square root of 81. Again, for the solution, so here 75 lies between 64 and 81. Okay, so if we are going to write them using the these symbols for inequality, so we have 64 is less than 75 and 75 is less than 81, and until we find the final answer, which is 8 and 9. So again, square root of 75 lies between 8 and 9. Example 3, between which two integers does 247 lies? So for this, you can do trial and error. Okay, since we have only obtained 100 a while ago, so we stop from to 100. So the next perfect square after 100 is 121. So that is the product when we multiply 11 times 11, and then 12 times 12 is 144. Okay, let us list that down, and then we will when we multiply 13 times 13, the result is 169. Okay, and then followed by what is this? So this is 11 times 11, 12 times 12, 13 times 13. How about 14 times 14? What is the result when we multiply 14 by 14? So we have 196. Okay, we're almost there. Next, let's try 15 times 15. The result is 225. And then the next after that, we have 16 times 16. The result is 256. Okay, so it is between these two perfect squares. Okay, it is between 225, or between the square root of 225 and the square root of 256. So this is 16 a while ago, right? If you're going to get the square root of this perfect square, it is 16, and this is 15. which means that square root of 247 is between 15 and 16. Again, here is our solution, and yes, it is between 15 and 16. For the next lesson, we are going to estimate the roots of a number. So this is quite familiar with our last lesson, okay, which is on estimating our roots of what is this? Identifying between which two integers an irrational number lies, okay? So again, our lesson or our next lesson is on estimating the roots of a number. Once again, this is teacher Mary Jane. Let's continue. Okay, conversion of radical numbers to fraction by approximation method. So this is the easiest method, right? So we will just approximate, but we will do trial and error. Okay, number one, find two consecutive perfect square integers between which the given number lies. So this is what we've done earlier. Next, find the distance from each integer. Okay, so we have to find the distance between these two integers. The distance of the radicand to the first integer is the numerator, while the distance of the two perfect squares, again, while the distance of the two perfect squares is the denominator of the fraction. Take note of that. The square root of the first perfect square integer will be the whole number and affix the fraction form to form a mixed number. Okay, that is quite complicated, but we can follow that as we answer some examples. Let's have example number one. So we follow the steps earlier to convert the square root of 40 in fraction form. Okay, so first we have for step 2, find the two consecutive perfect square integers between which the given number lies. Okay, this is just an extra part, so let us erase that. So square root of 40 lies between square root of 36 and square root of 49. Next, find the distance from each integer. The distance of the radicand to the first integer is the numerator, while the distance of the two perfect squares is the denominator of the fraction. Okay, so when we apply this, so we are going to find first the distance between 36 and 40. So 40 minus 36 is 4, and it says there 4 will be our numerator. So here is our fraction. And the next, while the distance of the two perfect squares, our two perfect squares here are 36 and 49. Okay, so when we subtract 49 minus 36, we will obtain 13. And that will be the denominator. So we have 4 over 13. The square root of the first perfect square integer will be the whole number and affix the fraction form to form a mixed number. So again, we go back to square root of 36. The square root of 36 is 6. That will be our whole number. And for our final answer, the approximated value of square root of 40 is 6 and 4 over 13. I hope you were able to follow those steps. Let's have another example. Okay, let us try to answer this activity. So we have the square root of 5. So let us approximate its value in fraction form by following the steps a while ago. Okay, so we have here the perfect square between which we could find the square root of 5. So it is between the square root of 4 and square root of 9. So 4 here is our A, and 9 is our B, and 5 here is our N. Okay, do not be confused. So that is N, A, and B. So when we subtract n minus a, so 5 minus 4 is equal to 1. After that, we subtract the value of b minus a, so the difference between these two numbers. So 9 minus 4, so that is equal to 5. And then we get the square root of the first integer. Our first integer is 4. The square root of 4 is 2. So that will be our whole number. We can now write them as a fraction. So our whole number is 2, and then our fraction is 1 over 5. Next, the square root of 29. So it is between the perfect squares 25 and 36. Then we subtract the value of b, or 29 minus the first integer. 25 minus 29 minus 25 is equal to 4. So that will be the numerator of our fraction. And then we subtract 36 minus 25. And we will obtain 11. 36 minus 25 is equal to 11. Now the square root of 5 is 5. The square root of 25 is 5. So this is our whole number. So writing them as a fraction, we have 5 and 4 over 11. Number 78. Number 3, so we have square root of 78. It is between 64, or square root of 64, and square root of 81. And then we subtract 78 minus 64. The result is 14. Next, we subtract the two perfect squares. 81 minus 64. The result is 17. So that is our denominator. Now we get the square root of 64 again, and the result is 8. We write them as a fraction, so square root of 78 is approximately 8 and 14 over 17. Next, how about the square root of 162? So it is between 144 and 169. So subtracting 162 minus 144, the result is 18. And then 169 minus 144 is 25. And the square root of 144 is 12. So we can now write it as a fraction. So we have 12 and 18 over 25. Now that we already know how to approximate the value of an irrational number, we can now plot them in a number line. So we have here an example. So we have letter A, square root of 5, B, square root of 29, C, square root of 78, D, square root of 162. So let us do a quick solution, or let us show a quick solution for this one. So square root of 5 is between the square root of 4 and square root of 9. So let me write it that way. And then to approximate its value, so we find first the whole number. So square root of 4 here is 2. And then the difference between 5 and 4 is 1. That will be our numerator. And then the difference between 9 and 4 is 5. So that is 2 and 1 over 5. Next, for letter B, we have square root of 29. So when we square root of 29 is between square root of 25 and square root of 36. Okay, so let me write it first. That means that our whole number is 5. And then subtract these two. We have 4 as the numerator. 36 minus 25 is 11. So we have 5 and 4 over 11. Square root of 78 is between square root of 64 and square root of 81. So we have 8 as our whole number because We have your square root of 64. And then subtract this to 78 minus 64. We have how many? 12. Am I right? Yes, 12 over subtract 81 minus 64. So this will be 11. 11 minus 4 is 7. So we have 17. 8 and 12 over 17. Next, square root of 162 is between the perfect squares 144 and 169. Square root of 144 is 12, and then 162 minus 144. Let me subtract that. So this will be 12, this will be 5, so 12 minus 4 is 8, so 18. And what's this? 169 minus 144. The result is 25. Wait. So 12 and 18 over 25. Let us check if it's correct. Yeah. So yeah, letter 8, square root of 5 is approximately 2 and 1/5. Square root of 29 is approximately 5 and 4 over 11. Square root of 78 is approximately 8 and 14 over 17. 14. Yeah, 12 minus 4 is 12 minus 4. Alright, so this should be 14. Wait. So this should be 14 because 78 minus 64 is 14. I'm sorry for that. So again, this is 14. This should be 14. And then for letter D, square root of 162 is equal to 12 and 18 over 25. Correct. We can now plot them in the number line. So letter A, 2 and 1/5 is approximately here. So we write the original given, which is the square root of 5. Okay, so it's up there. And then we have the value of square root of 29. Again, 5 and 4 over 11. So it is approximately in this part. Square root of 78 is equal to 8 and 14 over 17. So it is approximately in here. And then square root of 162 is approximately 12 and 18 over 25. So it is approximately in this part. All right. So that is how you plot irrational numbers. All right. So to check your understanding of our lesson, so let us try to answer this activity. So in the first column, we are going to identify the radicand. Second column, the root, and then the principal root. Okay, first we have the radicand 100, 6,561, 243, negative 729, 3,125, negative 4,096, 7,776, negative 1,000, negative 121, 16,807. Now let us look at the roots. So square root, we have the fourth root, fifth root, cube root, fifth root, fourth root, fifth root, cube root, square root, and fifth root. So let us identify first if there are not defined or the principal root is undefined. If the given radicand is negative and the root is even. So this is negative, but the root is odd, so that is okay. Here we have a negative radicand and it is even. So this is not defined or undefined. Next, we have here a negative radicand, but it is odd, so that is okay. The root is odd. But for the last one, or this one, we have negative 121. It is asking for the square root. Square root is even, so that is also not defined. Okay, I think we can now solve for the roots of the given. So one square root of 100 is 10. Fourth root of 6,561 is, what number can we multiply to get the value of 6,561? So this is 9. Next, the fifth root of 243. So the result is 3. And then the third root, or the cube root of 729. Since it is a negative number, so the answer is negative, and that is 9. Next, 3,125, its fifth root. So the answer here is 5. Next, 7,000, the fifth root of 7,776, and that is positive 6. Next, it is a negative number, so the result there is 10. And for number 20, 16,807, fifth root of 16,807, and the result is 7. Next, activity. For this activity, we approximate the square roots to fraction form. The first one is done. Okay, so square root of 15 is between the perfect squares 9 and 16. Square root of 39 is between 36 and, what's next after 36? 49. Next, 50 is between 49 and 64. 83 is between 81 and 100. 152 is between 149 and, what's next after 149? I mean, it is 144, not 149. Let me erase that. Okay, so what it is between 144 and 169. Next, we have 225, and it is between 225 and 256. Square root of 319 is between 289 and 324. 399 is between 361 and 400. Square root of 415 is equal to is between 400 and 441. Square root of 815 is between 784 and 841. Now let us subtract n minus a first. So 15 minus 9 is 6. 39 minus 36 is 3. 50 minus 49 is 1. 83 minus 81 is 2. 152 minus 144 is 8. 253 minus 225 is equal to 28. 319 minus 289 is equal to 30. 399 minus 361 is equal to 38. 415 minus 400 is equal to 15. And then 815 minus 784 is equal to 31. Those are our numerators. Let us subtract b minus a. Alright, next column. So subtract the perfect squares. So 16 minus 9 is 7. 49 minus 36 is 13. 64 minus 49 is 15. 100 minus 81 is 19. 169 minus 144 is 25. 256 minus 225 is 31. 324 minus 289 is 35. 400 minus 361 is 39. 441 minus 400 is 41. And 841 minus 784 is 57. And then square root of the, what's this? The square root of the first integer. So first, the square root of 9 is 3. Square root of 36 is 6. Square root of 49, 7. Square root of 81, 9. Square root of 144, 12. Square root of 225, 15. Square root of 289, 17. Square root of 361 is 19. Square root of 420. Square root of 784 is 28. Alright. So we write them as fractions now. So number 26, we have 3 and 6 over 7. Number 27, we have 6 and 3 over 13. Number 28, we have 7 and 1 over 15. Number 29, we have 9 and 2 over 19. Number 30, we have 12 and 8 over 25. 31, we have 15 and 28 over 31. Number 32, 17 and 30 over 35. Wait, let me check that. Yeah, so it's correct. So we can still simplify this. 17 and 6 over 7. Next, we have 19 and 38 over 39. Next, 20 and 15 over 41. And the last one is 28 and what is this? 31 over 57.